Okay, yesterday you guys did multiplying and dividing. Today we're going to add and subtract. Now you'd think that adding and subtracting would be easier. However, it's actually more difficult. Because when you do fractions, multiplying and dividing are really simple. You just push them together and cancel. Or flip it, push it together and cancel. But with fractions, with adding and subtracting, you need a common denominator. A least common denominator is preferable because you don't want to make it bigger. So, first thing you got to do, let's remember how to add our fractions together. I'll give you a nice little intro. Why don't you guys pause the video and see if you could add these fractions together before I do it. See if you remember how to do this. Alright, so anyway, we need a common denominator. The lowest one that we could probably get that they have in common is 40. So how do I get a 40 on the bottom for both of these? I have to multiply this by 5, but you have to do the top and the bottom because what this is just a basically 1, right? And you can multiply anything by 1 and keep it the same. Same thing here. We need to multiply the top and bottom by 8. And this is again the LCD. The LCD here is equal to 40, or 8 times 5. So what I get is 16 40ths plus 15 40ths. So I get 31 over 40. That's my answer. So this is the same for rational expressions. So for these expressions down here, we need to find an LCD and then push them together. The first two, I only want you to find the LCD. So let's look at this. This denominator has an x plus 4 and an x. So the LCD for this one is that both fractions have to have an x plus 4 times an x. So we'd multiply this one by x over x, we'd multiply this one by x plus 4 over x plus 4, and then we could combine these. Before we do this one, we probably should factor it. And we have a minus 2 and a minus 3. And over here we have a minus 3 and a plus 4. So our LCD, things we need for the bottom. Well, there's an x minus 2 term, an x minus 3 term, and an x minus 4 term. So our fraction at the end will have an LCD of x minus 2, x minus 3, and an x minus 4. That's all that we require. You can do more, but it gets sloppy then. Alright, so, and I should say x plus 4, by the way. That's an x plus 4, because that's what it is. Alright, now, let's simplify these. Same thing. First off, look at the denominators. Number 3 is kind of nice because this is x plus 3 and this is x plus 3. They have the same denominator. We do not need to find the LCD because it is x plus 3. So, we can just subtract them. The final answer is 2x minus 4 over x plus 3. Now, if I want it in factored form, you can do this just to get in the habit of keeping everything in factored form, just to look at it. That would also be okay. I don't mind, as long as that is the case. But with subtraction and adding, there should be one fraction at the end with terms. So like a 2, an x minus 2, and an x plus 3 are all multiplied terms. You should not have a minus sign between two fractions. Alright, let's look at number 4. Before I do anything, I need to simplify this. So, I am going to just look at what this looks like when I factor it. 4x plus 4, that's x plus 2 and x plus 2. And then I have a minus 2 over x plus 2, x minus 2. Okay, so my LCD here, I'm going to just write it out so I can work with it later. I need two x plus 2's and an x minus 2. You need both of them because there's already 2 under this fraction. Okay, so that means that for this side I need to multiply by x minus 2 to get an LCD, and this side needs to be x plus 2. Now when on the bottoms you leave them in factored form. So, tops though you multiply it out. So when I multiply these two together I FOIL and I get x squared minus 2x plus x is a minus x plus, it should be minus 2. All this is this right here. I multiplied those two together. Over. And actually now we can keep our same denominator. We have x minus 2, x plus 2, squared. I'm just going to write it as squared so I know that they're together. Now here's the key though. When you are subtracting, this subtraction sign goes here. We're subtracting this whole thing. Okay? So 2 times x plus 2 is 2x plus 4. Notice how the minus sign has to be distributed here. The final step now is to distribute that minus sign. So I have an x squared, I have a minus x minus a 2x. This will become a minus 3x. I have a minus 2 minus 4 is a minus 6. And then we have x minus 2 and x plus 2 quantity squared. We have now combined it into one fraction. You can try to factor this, but most of the time, well, let's try factoring it. It's either 2, 3 or 1, 6, and that there's no way to get a 3 out of those, so it's not factorable. So that would be the final answer. Again, the keys, factor, look at your GCF. So for example, this one here, if I factor this, I have a 5 over, well, this one is kind of it's factored already. And I have a 4 x squared minus 3, which is not factorable. So we have to look at this and go, well, what do I need on the bottom for my LCD? So my LCD for this problem is, well, for numbers, we have a 6 and a 4. What number can I get to with both of those? I can get those both to 12. So that's the lowest number that I can use for that. I have an x squared term that's by itself. I need an x squared term then. And then I have this other term, x squared minus 3. Now, it is a separate term because it has a subtraction symbol in there. You cannot say, well, we already have the x squared though, so we need a minus 3. No, this is a term and this is a separate term. So my LCD is this. So my denominator needs to look like that for both pieces. So for this first piece, I have 5 over 6x squared, and I need to get to 12. I need to multiply the tops by 2 and 2, and then I need this x squared minus 3. So I also have to multiply by x squared minus 3 on the top and the bottom, and that is now okay. Now we add it to this one over here. I have x on top, and I have on the bottom a 4 and an x squared minus 3. Well, I need to get this 4 to 12, so I need to multiply the tops and the bottoms by 3. And now I have my 12, and then I just need an x squared. Okay. Now this should have the same LCD. So I multiply out the tops here. And remember, the tops you do want to multiply out. So I get 5 times 2 is 10, and then it's 10x squared. And then 10 times negative 3 is minus 15. Nope, minus 30. Because you need the 2 in there too. So 5 times 2 is 10. 10 times negative 3 is minus 30. And there's no x involved. And then we have plus, when you multiply all that, you get 3x cubed. Okay? Now, we are done with that. And that's over our LCD of 12x squared times x squared minus 3. And then we just reorder it because we like to look at this ordered correctly. So we have 3x cubed plus 10x squared minus 30 over 12x squared x squared minus 3. Okay, now let's look at the next one. There's only one more. So this will be your final answer because you can't factor it anymore. And let's look at the last one. The last one. There's two ways to do this one. There's a quicker way and a longer way. Now on this one, some of you guys might go, wait, x over x, isn't that just 1? Yes, it is. So the quick way is turning this into a 1 plus x plus 2 over x plus 3. Well, in order to add this fraction to 1 over 1, the LCD just needs to be x plus 3. So that means that I just have to multiply this side over here by x plus 3 over x plus 3. So those are my groupings. Plus x plus 2 over x plus 3. So now when I add these fractions together, I get 2x's plus 5 over x plus 3. And that's the quick way to do it. If you did not see that right away, you would look at this and go, okay, my LCD is actually x times x plus 3. So we would multiply this side by x plus 3, which would be x times x plus 3 over x times x plus 3, plus this side would be x. And then when you multiply these out, let's see what happens, just to show you that it's the same thing. You get x squared plus 3x plus x squared plus 2x all over x times x plus 3. When you combine like terms, you get 2x squared plus 5x over x times x plus 3. And then you could factor out an x on top. Which, what happens? Sure enough, these end up canceling again. So we are left with our final answer of the same thing that if you canceled them initially. Okay? So that's adding and subtracting fractions. Again, the bottoms need to match, and then you add or subtract the tops only. Quick review.